So without any further ado, Björn, are you there?
Yes, I'm here.
Excellent. So why don't you just share your screen and take it away?
Yeah, we'll do that. So thanks a lot to Things and Magnus and the Things team for inviting us to participate at this event. Smart electrification, that's exactly the core of what we do. So I think that sums it up very nice in one sentence. Back to Ferroamp. I'm Björn Jernström. I'm the founder and of the company, and now work as CTO. And just Ferroamp in a nutshell. So we are quite fast growing. We had last year we had revenues of or net sales of about 77 million SEK, and we have been growing quite fast the previous years and also this year. And we provide a hardware and a software platform to integrate solar cells, energy storage, and electric vehicle charging into facilities. Before jumping into the technology and the products, I would just like to start with a small outlook on the market and the different trends we see around us, just to put our products in perspective. The first thing that we can notice is the fact that solar cells is here to stay. This is one example from Portugal 2 years ago, or 2020, where new solar installation can produce electricity for 0.01 euros per kilowatt hours. And that is extremely low. That can be compared to the electricity price in Stockholm right now, which is about 30 times higher than the price for this for energy from this solar installation. So even though solar is expanding rapidly, we have only seen the beginning. Another trend that we can see on the market is the electric vehicle introduction, and it's no longer a question if or when the electric vehicles will take over, because that's actually happening right now as we speak. Last month was actually the first time where more than 50% of new car sales in Sweden were electric. So the race is over. And another thing that I wanted to share, another trend, is when it comes to batteries. In northern Sweden, there is just now an industrial investment going on, which is one of the biggest that ever has happened in Sweden. So it's a sort of a new industrial revolution in terms of batteries. And the picture here shows one of the gigafactories, and this is just one of these massive battery factories that will be required to meet the battery needs of Europe alone. So all of these technologies, solar cells, energy storage, and electric vehicle, they are fantastic because they are technologies that exist, that they work, and they're profitable, and they are important tools in solving the climate crisis. But they don't come without challenges. So I mean, if you have batteries, it's quite difficult to control them. When should you charge? When should you discharge? How much should you charge? When it comes to electric vehicles, charging them will pose a lot of challenges on the local electric grid in buildings and in local communities. And with solar cells, you have the challenge that, well, the sun doesn't shine during night, and sometimes you have a lot of energy, but it's needed somewhere else. So all of these create challenges, and this is where Ferroamp comes in. And a lot of these challenges has to do with the grid, because transporting electricity is becoming increasingly expensive. The graph here shows the comparison where the blue bar represents the value of all the energy being consumed in Sweden during 1 year, and the red bar represents the grid costs. So that is essentially the cost for transporting the electricity from the power plant to your home or to the outlet. And already today, it's more expensive to transport electricity than it is to produce it. So the logical conclusion here is that, well, the more we can produce locally, store locally, and consume locally, the better benefits you will have. And that is exactly where Ferroamp comes in. And just to illustrate some of the consequences, this is quite, well, I shouldn't say funny, but remarkable. Yesterday we had one of the highest price peaks ever, where electricity costs were 5.5 crowns per kilowatt hour. And this massive volatility obviously creates a big need for batteries, because batteries is one of the key things here to be able to mitigate this volatility, in addition to load control and a lot of other means. And part of these really large price variations is actually due to grid congestion. You can see here in the large screenshot from Nord Pool, the energy exchange, the upper two green traces are from the southern part of Sweden, whereas the lowest two green traces are from the northern part of Sweden. So there's a massive price difference between the northern part of Sweden and the southern part of Sweden, and that is because of grid congestion. And this is where Ferroamp's platform comes in. So what we're doing is a platform to integrate solar cells, batteries, and EV charging. Part of this is hardware products, as you can see on the right-hand side. So it's bidirectional inverters to convert between DC from solar cells or batteries and to the AC grid. But it's also DC-DC converters and battery systems. So we get a complete product portfolio to manage and control power flows. But even more important than the actual hardware products is the software platform. This is both running locally on the system, but also on the cloud. And that allows our customers to control and visualize and monitor how much energy they produce, they consume, and store. And the software platform is also where we see a lot of new functionality growth, and the software platform is something that enables a lot of other features to be connected to the system. And what is unique with our system is that we have based it using DC grid technology. So we have chosen a 760 volt DC level, and the benefits with integrating these new animals, because solar cells, they are inherently DC devices. Same thing goes with batteries, they are DC devices. Electric vehicles are DC devices because they are batteries on wheels. And all your normal appliances, they need AC. So this is one of the reasons why it makes sense to interconnect all of these new things that come into our buildings using a DC grid. And the benefits there is that we can then integrate this into one system using only one converter, one single point of inversion between DC and AC. We also reduce conversion losses, and we get the modularity at the same time. So these are some of the benefits that we get. And one of the really unique things is that once we have a DC grid in one building, we can actually extend it to connect multiple buildings. This is something that we call power share. And this allows local resource sharing. So you can have solar installations on the best roof in a group of neighboring buildings, and then you can share the energy using a local DC grid. And this increases the profitability with solar cells, with batteries, and with fast EV chargers. And this is actually a bit controversial, because we are essentially competing with the traditional grid monopolies. But we got an early Christmas present from the Swedish government this year. 1 month ago, the parliament passed a legislation that allows this in Sweden from January 2022. So particularly for all the housing associations or bostadsrättsföreningar in Sweden, this will be a very good solution. And we also see legislative proposals in other member states, because this is very much in line with the new e-directive from the European Commission. So we have already seen that this has already passed a similar legislation in the Netherlands, and we expect to see similar trends in other countries in Europe. And So speaking of that, I thought that I wouldn't mention so much more about the technology, but rather we could jump to some of our customers to see how they are using our technology, just to give you an example of how this can be implemented. And the first example is actually one of these power sharing installations. This is from an installation in Västervik. It's a hotel, and it comprises two different buildings, one floating on water and one on land. And these are interconnected using a DC grid, and then we can divert solar energy to the building that needs it the most. So we're sort of steering solar energy to where the consumption is. And this is something that reduces the grid cost for them and also increases the self-consumption of solar electricity. So really interesting application. The next example is another housing association, this one in Gothenburg. And the thing that differentiates this is that we have second life electric bus batteries, Volvo bus batteries in the basement. So here we use solar energy from the rooftops, and we store it in the batteries during the daytime, and then we can use energy during the night. And we can also use the batteries now in wintertime for peak shaving. So we reduce the peak consumption from the grid. And this is particularly interesting now when the electricity price is so high during the daytime. Everything that you see here is all of our installations are built using this DC grid technology. Here's another case. You know, I mentioned that charging a lot of electric cars is somewhat of a challenge. Then we can use a solution like this. This is a 20-foot container filled with batteries and converters, and then we can charge it from the grid in a slow pace. And then you can come up with a lot of cars, or in this case, you can come up with up to 8 cars and fast charge at the same time, or as in this case, electric snowmobiles. Here's another case. This is a parking garage at an insurance company in Holland. This is actually our largest installation to date. It's 840 kilowatts, so close to 1 megawatt. And the entire system is DC based. So the idea here is that today they have solar cells, they have battery systems, and we will also complement this installation with DC chargers to a lot of these parking places. And the idea here is, of course, that you could use solar energy much more efficiently by being able to store it on DC and use it on DC, so you avoid all the conversion steps that have higher losses. Here's another installation. This is in Akademiska Hus in Gothenburg. This is a new office building where essentially everything is powered by DC. So all the public lighting, about 1,500 light points, is powered by our DC grid. Also, the entire heating ventilation system is powered by DC. So this is actually, to our knowledge, the world's biggest DC powered office building. Really exciting installation. And the last example I wanted to show you is from the Swedish pavilion in Dubai that was inaugurated about a month ago. So here we have thin film solar panels on the facade from Swedish manufacturer Soltech, and we also have batteries here so that we can use the solar energy in the evening and in the night. So the idea here is that the pavilion should be as self-sufficient as possible. So to summarize this, on the last 12 months, we have focused quite a lot on securing new partnerships, and mostly in Sweden so far. We have one in Holland with Indotech, and we have also started to launch our new generation of products, which are more industrialized, and all our volume production is now outsourced. So the things that are our strategic focus in the coming year is growth, and that is to expand within new markets in Europe. So if someone is interested in helping us there and have some channels for us to enter new countries in Europe, we would be very interested to talk to you. And the second thing is margin development. So and that is essentially industrializing the remaining products which are not really or not yet up to generation 2.0 when it comes to industrialization. So that is one important thing. And also looking at software-based services is another important thing, because the system we have today collect a lot of data. We generate typically 1 second resolution data from all our installations. So we have, I think that we have, even though we just have about 3,000 installations in operation today, I think we have more energy data than the big grid companies in Sweden. Yeah, so that's essentially a very short version of Ferroamp. And if you're in Gothenburg end of this week, you can visit us at eCar Expo, where we will launch some new cool stuff. And if you're in Munich next year, you can also visit us at Intersolar. Thanks.
Brilliant, Björn. Thank you so much. I love to hear this story over and over again. So that's great. Let's see if we have questions. Feel free to put any questions during the presentations and after on the chats, and I'll try to raise the questions to the speakers. We don't have any right now, but normally I ask, since we have some investors in our events, I always ask you about the financing of the companies and so forth. I happen to know that you're listed already, Björn, but maybe you can give a quick update on that.
Yeah, so we're listed on Nasdaq First North, ticker Ferro, and our market cap today is about 1 billion Swedish crowns, and we do not have any immediate financing needs right now. We closed a round with, we got in a facility company, Wallenstam, as investor about 2 months back. So we're really happy for that. They were actually one of our, they are actually one of our customers. So they have about 15 of their facilities. And so obviously they were quite happy with those. So we're quite proud to have them on board as one of the bigger shareholders today. That being said, you never know when we obviously want to grow faster. So there will always be room for new investors.
Great. I have a question for you here from the audience. So what's your view on second life batteries? How did the residential project go?
I think there is residential or second life batteries. They are quite interesting, but they are also quite challenging, particularly when it comes to making the installations cost effective. Because second life batteries, even though they could have a long lifespan left, it's really difficult to determine the remaining lifetime. So that means it's difficult to sell second life batteries. So I think that in order to be successful, you probably need to have a business model where you provide energy storage as a service, so that you have access to the site. You can replace the batteries if they wear out before you expect. And also it's very important that you find an industrialized way to use them, because depending on the car manufacturers, you may not be allowed to use the batteries exactly as they are in a car, because that's typically what we talk about when it's second life. It's second life batteries from electric vehicles. So if you need to somehow disassemble and reassemble the batteries, then it's very difficult to do that in a cost-effective way. So I think that you need to do it in cooperation with the car manufacturers. You can use the battery pack as is. And that means that you also need to have access to some of the communication protocols and specifications. And this is a challenge. Yeah, I think that there are great opportunities with second life batteries, but it's also a challenge to make it in a cost-effective way. Great.
I have another final question to you, Björn, before we move forward. So for all those people who just saw this and said, Jesus, I want one of those myself. How is this a consumer type product? Do you sell this to individuals in houses as well?
Yeah, about 3,000 installations today. I would say a little bit more than half are like private villa owners, so single family homes. And the other half is commercial real estate. So it's definitely something for a private individual, particularly if you're buying an electric vehicle. I think that we have really good solutions there that can help you charge your car faster or without problems. And the easiest thing then is to, you can look at our website, and there you have all our resellers and distributors, or you can contact your local electrician and say that you heard about this company Ferroamp and you would like to have their solutions for enabling faster charging of your car or reducing your grid fee or integrating solar cells on your building.
Wonderful. Thank you so much, Björn. And we'll move forward to our next speaker,